On the night of April 29, 2026, three separate Russian frontline brigade commanders along the Donetsk axis transmitted emergency requests to their divisional headquarters within a 40-minute window of each other. They were not reporting Ukrainian breakthroughs. They were not requesting reinforcements or medical evacuation. They were reporting that their units had run out of a specific category of battlefield consumable so fundamental to modern combined arms warfare that its absence did not just degrade their operational capacity, it stopped their operations entirely. The item was not a sophisticated precision weapon. It was not a rare electronic component sourced through a covert import network. It was artillery propellant charge sets, the chemical propellant packets that give a shell its range and velocity when it leaves the barrel of a howitzer. Without them, Russia's artillery, the single most strategically important instrument of its entire ground campaign, cannot fire, and on the night of April 29th, across three separate brigade sectors on Russia's most active operational front, it did not. For analysts who have spent the past 2 years watching Russia sustain an artillery output rate that NATO partners have struggled to match, this was not a data point they expected to see. Not now, not at this stage of the war. The shock was not that a supply disruption had happened. The shock was what the disruption revealed about the system underneath it, a system that is failing in ways that Russia's publicly projected production numbers have been successfully concealing for months. If this is your first time here, and you want the analysis that goes beneath the surface of this war, the systems, the failures, the real operational picture, hit like and subscribe right now, because this is exactly what this channel delivers. Now, let's get into it. The propellant shortage on the Donetsk axis was confirmed through multiple independent channels within 72 hours of the April 29th incident. Intercepted Russian military communications, reviewed by Ukrainian military intelligence and shared, in summary form with European defense partners, contained explicit references to a supply chain failure at the level of the central propellant distribution depot responsible for servicing the Eastern Operational Grouping. Open-source analysts monitoring Russian artillery activity through acoustic detection data and commercial satellite imagery noted a statistically significant drop in Russian artillery firing rates across a 40-kilometer stretch of the Donetsk front between April 29th and May 3rd, a drop of approximately 35% from the 7-day average preceding the incident, and a serving Russian contract soldier evacuated to a field hospital during the same period and subsequently interviewed by a journalist working for a Baltic news outlet with established frontline sourcing, described his battery as having been issued approximately 40% of its standard daily propellant allocation for 3 consecutive days before the interview, with no explanation provided by his chain of command. 3 independent data streams. 1 conclusion. Something inside Putin's war machine had failed. And analysts, including senior researchers at ISW, RUSI, and CSIs who have spent years tracking Russian military logistics, described their assessment of the situation in terms that range from surprised to genuinely shocked. But the propellant shortage itself was not the real story. The real story was what the shortage exposed about the structural condition of Russia's military-industrial supply chain, a chain that has been presented publicly by Russian state media and implicitly accepted by a significant portion of Western defense analysis as having been successfully adapted to wartime conditions. The real story was that the adaptation was shallower than it appeared, more brittle than the production numbers suggested, and vulnerable to a category of systemic failure that Russia's military planners had not adequately prepared for. And to understand why that matters for the operational trajectory of this war, you first need to understand how Russia's artillery supply chain actually works, what it was designed to handle, and where the specific weakness that produced the April 29th failure had been quietly developing for over a year. To understand what failed inside Russia's war machine, you first need to understand the architecture of Russian military propellant supply and why it is structurally different from, and more vulnerable than, the artillery shell production. Numbers that dominate Western assessments of Russian logistics capacity. When analysts cite Russia's artillery output figures, the 250,000 shells per month estimate that NATO sources referenced through late 2025. Those figures measure completed shell production at the manufacturing level. They do not measure the complete supply chain required to get a functional artillery round to the barrel of a howitzer on the Donetsk front. A functional artillery round has two essential components: the projectile itself, which is what the shell production figures count, and the propellant charge set, which is manufactured through an entirely separate industrial process, stored in separate facilities, transported through a separate logistics chain, and issued to artillery units through a separate distribution system. The propellant production process is chemically complex, requires specialized precursor chemicals, several of which Russia imports or imported through covert channels, and is concentrated in a small number of dedicated propellant manufacturing facilities rather than distributed across the broader Russian defense industrial base. Russia has, since 2022, successfully scaled up projectile production by repurposing and expanding multiple existing metalworking and explosive drilling facilities. It has not achieved equivalent scaling of propellant production, for the straightforward reason that propellant manufacturing cannot be quickly transferred to facilities that were not originally designed and equipped for it. The result, which defense logistics analysts at Russia have been tracking with increasing concern through late 2025, was a growing structural imbalance between Russia's ability to produce artillery shells and its ability to produce the propellant charges required to fire them. The April 29th incident was the moment that imbalance became operationally visible on the front line. The specific propellant depot failure that produced the April 29th shortage is the detail that crystallizes everything about how a structural supply chain weakness translates into a frontline operational crisis. The central propellant distribution depot responsible for servicing the Eastern Operational Grouping, the facility whose failure the intercepted communications referenced, was not a new installation. It was a Soviet-era storage and distribution complex that had been brought back into full operational service in 2023, after years of reduced capacity maintenance, as Russian military logistics planners attempted to compensate for the propellant supply imbalance by drawing down strategic stockpiles accumulated during the Soviet period and maintained it at reduced levels through the post-Soviet decades. Those strategic stockpiles were, in the assessment of Michael Kofman and other senior analysts tracking Russian military capacity, one of the hidden buffers that had allowed Russia to sustain its artillery tempo through 2024 and into 2025, despite the propellant production shortfall. The Soviet Union had stored propellant at scale. Russia had been consuming that inheritance, and by the spring of 2026, according to logistics assessments cited by ISW, the Eastern Operational Grouping's primary propellant depot had reached a stock level at which normal distribution operations were no longer sustainable without either a significant reduction in frontline artillery activity or a compensating increase in propellant deliveries from manufacturing sources. Neither happened in time. The depot continued issuing at operational rates until it could not. And then 3 brigade commanders sent their emergency requests within 40 minutes of each other. And analysts looking at the data found themselves staring at something they had expected to see eventually but not yet. The full arc of Russia's propellant crisis deserves to be told from its true starting point, which is not April 2026 but the summer of 2022, when the first serious assessments of Russia's propellant supply vulnerability began circulating in classified Western defense intelligence channels. The early assessments identified 3 specific propellant precursor chemicals, compounds used in the synthesis of the type nitrocellulose and nitroglycerin-based formulations that Russian artillery propellants require, that Russia sourced predominantly from Western suppliers prior to sanctions. Those imports were cut off in early 2022 with the initial sanctions packages. Russia had approximately 12 to 18 months of precursor stockpiles, depending on the compound it pursued, substitute sourcing through multiple channels, some domestic synthesis expansion, some covert import through third-country intermediaries, some reformulation of propellant specifications to reduce dependence on the most restricted compounds, None of these substitution efforts fully closed the gap. Domestic synthesis expansion was constrained by the same specialized facility bottleneck that limited overall propellant production scaling. Covert import networks, including the channels later associated with Operation Grey Mirror, provided partial relief but at volumes insufficient to compensate for the loss of Western supply, and propellant reformulation introduced quality consistency issues that Russian artillery units began reporting through their maintenance and performance channels as early as late 2023 reports that described increased barrel wear rates, inconsistent muzzle velocities, and reduced effective range on reformulated propellant batches compared to pre-war specification rounds. By 2024, the Russian artillery system was simultaneously consuming propellant faster than it could be produced, drawing down Soviet-era strategic reserves to compensate, and fielding a portion of its propellant supply in reformulated batches that degraded the performance of the shells it was producing in record numbers. The April 29 failure was the culmination of a process that had been developing for nearly 4 years. Step back now to the full campaign picture, because the propellant crisis does not exist in isolation. It sits within a broader pattern of Russian military-industrial stress that, taken together, describes a war machine that is operating closer to its sustainable limits than its publicly projected production capacity would suggest. Russia's shell production figures are real. Its drone production expansion is real. Its continued ability to conduct offensive operations across multiple axes simultaneously is real. None of that is in dispute. What is increasingly in dispute among analysts who are looking at the full logistics picture rather than the manufacturing headline numbers is the question of sustainability, whether the rate at which Russia is consuming its military capacity across all categories can be maintained at current levels without generating the kind of systemic failures that the April 29th incident represents. The propellant crisis is one node in a pattern that includes the ongoing barrel wear problem. Russian artillery tubes are being consumed at rates that the domestic manufacturing base is struggling to replace, with multiple frontline units reportedly operating guns beyond their recommended service life. The continued dependence on covert import channels for precision electronics that Ukraine has been systematically disrupting, and the personnel quality degradation that comes from sustaining casualty rates at the levels Russia has been absorbing since the beginning of large-scale offensive operations in 2023. Each of these stress points is individually manageable. Together, they describe a system that is burning through its buffers, the Soviet stockpiles, the pre-war equipment reserves, the experienced personnel base, faster than it is reconstituting them. The April 29th incident was the first time one of those buffers ran out in a way that was immediately and visibly consequential on the front line. It will not be the last. There is one further dimension of this failure that has not received adequate attention in the coverage that followed the April 29th incident, and it matters enormously for understanding the strategic trajectory of the coming months. The Russian military's response to the propellant shortage, both in the immediate operational management of the crisis and in the subsequent communications to higher command, revealed a logistics reporting system that had been presenting a systematically optimistic picture of supply chain health to commanders at the operational and strategic level. Multiple intercepts reviewed by Ukrainian intelligence, according to sources cited in briefings described by Radio Liberty, showed that the propellant shortage had been flagged at lower levels of the Russian supply chain more than 6 weeks before the April 29th frontline impact, but that those flags had been moderated, reframed, or simply not transmitted accurately as they moved up the command hierarchy. This is not an unusual pathology in large military bureaucracies under political pressure to project competence and sustainability. It is, however, an extremely dangerous one, because it means that the commanders and planners who are making decisions about operational tempo, offensive scheduling, and resource allocation are doing so on the basis of logistics data that understates the true level of supply chain stress. The April 29th incident was a shock to analysts on the outside. It appears to have also been a shock to Russian operational commanders who believed based on the reporting they were receiving that their supply position was more secure than it was. That gap between reported reality and operational reality, between what the system says is happening and what is actually happening at the depot and the battery level, is perhaps the most consequential failure that something huge revealed inside Putin's war machine. Not the propellant shortage itself, the fact that nobody at the top saw it coming. Here is the final strategic reality that the April 29th propellant failure eliminates. Russia has sustained its artillery-dominant campaign strategy on the implicit assumption that its logistics system, however dependent on Soviet-era buffers and covert import networks, would degrade gradually and manageably rather than fail suddenly and visibly. The propellant crisis breaks that assumption. It demonstrates that the degradation is not uniformly gradual, that within a system that looks sustainable in aggregate, there are specific nodes and specific supply chains where the buffers have run out faster than the overall picture suggests, and where the failure mode is not a slow reduction in capacity but an abrupt operational halt that exposes the structural weakness all at once. The old assumption that Russia's logistics are stretched but holding has been replaced by a more uncomfortable and more operationally significant reality that Russia's logistics are stretched in ways its own command system did not fully understand until a frontline failure made the picture impossible to misread. The question now is not whether similar failures will occur in other supply chains. The barrel wear data, the personnel quality signals, and the precision component import disruptions all suggest they will. The question is whether those failures occur at a pace and scale that Ukraine and its partners can exploit operationally before Russia identifies and addresses the specific bottlenecks that are generating them. That is the most important logistics question in this war, and after April 29th, it is no longer a theoretical one. What do you think this comes down to? Does the propellant failure represent an isolated node failure inside a system that Russia can stabilize and compensate for? Or is it the first visible fracture in a logistics architecture that is approaching a broader and more systemic breaking point that will reshape the operational balance before the end of 2026? Tell me in the comments. And if this channel is where you come to understand what is actually happening inside this war, beneath the production numbers, beneath the frontline maps, down to the level of the systems that are holding and the ones that are not, make sure you are subscribed, because the story that is developing here is far from over.